Just to run through the basics very, very quickly, you've seen graphs like this all over the place. You know that over on the left there it shows you average increases in temperature. And what we have here with this top line is the kind of small-scale changes happening over the last few years. That black line at the bottom is where ordinary temperature projections would have taken us had there not been this anthropogenic, this man-made addition to natural background forces. So this is the sort of stuff that lies behind it. That led, of course, amongst other things, to the consensus from the Intergovernmental Panel on Climate Change, the body set up by governments to advise governments, which in 2007, in its fourth assessment report, steered government towards this kind of science consensus. Absolute consensus that we shouldn't let the temperature increase by more than an average of 2 degrees centigrade by the end of this century, which means that we'd have to move towards stabilization of greenhouse gases at around 450 parts per million. And then from there, you can cascade that through to the level by which you'd need to reduce those greenhouse gases to ensure stabilization at around 450. And here in the UK, as you know, we have a long-term target of an 80% reduction in those greenhouse gases by 2050. I'll come back and say a bit more about that in a moment. Very strong consensus about this. Big question mark now whether this consensus is any longer quite as robust and helpful to us as we would like it to be. Some of you may have seen at the end of last week and earlier this week some of the latest data about CO2 concentrations in the atmosphere over the Arctic. Now, you have to be careful about this particular piece of research from the Norwegian Polar Institute because people recognize that CO2 concentrations are higher at the polar extremes, and this particular figure, which they surfaced recently, is the highest that we've ever seen. So CO2 in the Arctic in the last few weeks has gone as high as 397 parts per million. Now, it's already coming back down again. That won't be the average for the year. I'm not putting it to you in those terms, but what I am reminding you of is that the upward curve here is extremely worrying. Essentially, between about 1970 and 2000, concentrations of CO2 grew by about 1.2 parts per million per annum. And since 2000, they've been growing by about 2.1 parts per million per annum. This increase is closer to 2.5 parts per million as an annual change since the last year. This is not a good story. This is heading very, very rapidly in the wrong direction. And scientists are beginning to concentrate now on some of the potential feedback loops in natural systems. In January, there was a very interesting piece of research looking at the degree to which the oceans are absorbing the same amount of CO2 as we hope they will go on absorbing into the long-term future. Because if oceans don't absorb the CO2 that they used to, guess what? It has to go somewhere. It doesn't just disappear out of the system, it goes somewhere. And that means it's likely to go into the atmosphere. And what we're seeing is in certain parts of the world that our oceans are now absorbing less CO2 than they used to do. Natural feedback loops are not part of the IPCC consensus. It's quite a worrying little reminder. So let's get serious about the language behind this. Please stop talking about things like CO2 mitigation. Language much beloved of governments, large companies. It isn't helpful. It sort of gives you the slightest indication of the nature of the challenge ahead. But really, we have got to start talking about systemic, radical, accelerated decarbonization as the only proper, responsible response to the science that we now have available to us. Anything else is linguistic fudge at best and blatant dishonesty at worst. That's the middle of the conundrum we're in now. The science should be driving policy, which should drive behavior change.